Imagine waking up on a June morning, looking outside and seeing snow. Not in Antarctica, not on a mountain. In New England, when farmers should have been watching their crops grow. Now imagine that nobody around you knows why it is happening. There are no satellites, no global weather maps, and no instant news from the other side of the world. Summer simply seems to have disappeared. The strangest part is that the answer was hiding more than 14,000 kilometers away, inside a mountain most of those farmers had never heard of. This is the story of the volcano that stole summer and may have helped create one of the most famous monsters in fiction. Our story begins in April 1815 on Sumbawa, an island in what is now Indonesia. Mount Tambora had been restless for years. Then on April 10th and 11th, the mountain exploded with extraordinary force. The eruption was rated a 7 on the Volcanic Explosivity Index, a scale that only goes to 8. Pyroclastic flows, fast, scorching avalanches of gas, ash, and rock, raced down the volcano. When some of those flows reached the sea, they triggered tsunamis. Villages were erased, crops were buried, and the summit collapsed into an enormous caldera roughly 6 kilometers wide. For a sense of scale, the U.S. Geological Survey estimates that Tambora released about 40 times as much magma as Mount St. Helens did in 1980, and about 10 times as much as Mount Pinatubo did in 1991. Tambora was not a movie volcano with one tidy explosion. It was a landscape-changing event whose local aftermath continued after the loudest blasts had stopped. The disaster killed people immediately, but hunger and disease made the final toll far worse. Modern estimates vary, yet Tambora is generally described as the deadliest volcanic eruption in recorded history. And the eruption was not finished with the world. Tambora blasted sulfur-rich gases high into the stratosphere. Ash looks dramatic, but most volcanic ash falls out of the atmosphere comparatively quickly. The longer-lasting climate effect came largely from sulfur dioxide. High above the weather, that gas reacted with water and formed tiny sulfate aerosols. Think of them as trillions of microscopic mirrors. They scattered and reflected a small portion of incoming sunlight back toward space. The change sounds tiny, but Earth's climate system is enormous, connected, and sensitive. A little less sunlight over a huge area can rearrange temperature and rainfall patterns for months or even years. By 1816, the Northern Hemisphere was experiencing bizarre weather. In parts of New England, frost arrived during the growing season. Snow fell in June. Crops failed or produced far less than expected. Hay became scarce, livestock suffered, and food prices climbed. These were farming communities that timed survival to the seasons. Seeds went into the ground with the expectation that spring would warm into summer. When frost returned again and again, families could not simply order food from somewhere else. A ruined field meant less food to eat, less produce to sell, and fewer seeds or animals for the following year. Europe faced cold, relentless rain and damaged harvests. Grain shortages pushed bread prices upward. For families already living close to the edge, a failed crop was not an inconvenience. It was a crisis. People at the time offered all kinds of explanations. Some blamed sunspots. Others treated the weather as a religious warning. Most had no way to connect a distant eruption in Indonesia with a freezing field in Vermont or a rain-soaked village in Switzerland. The atmosphere had delivered a message around the planet, but humanity had not yet learned how to read it. This is why 1816 became known as the year without a summer. It was not literally cold everywhere on every day. That nickname compresses a complicated global event into 5 memorable words. Different regions experienced different combinations of cooling, rain, drought, and disrupted seasons. But in Europe and northeastern North America, the pattern was severe enough to alter daily life. Farmers moved, markets shifted, fisheries changed, hunger increased. The effects traveled through society just as surely as the volcanic aerosols traveled through the sky. New England offers a surprising example. Researchers studying old weather records and fish exports found that 1816 was also remembered as the mackerel year. Cold conditions disrupted familiar freshwater and coastal fisheries, while mackerel became unusually important. Communities adapted by changing what they caught and sold. Other families adapted by leaving. Crop failures helped encourage movement away from colder northern farms toward places with more dependable growing seasons. Tambora did not choose a migration route or make a person pack a wagon, but it changed the pressures behind thousands of individual decisions. Across the Atlantic, grain shortages helped drive prices and public anger upward. One historical summary describes English rioters demanding bread or blood. Those three words make the climate connection painfully human. A change in sunlight became a change in harvests. A change in harvests became a change in prices. And a change in prices became unrest in the street. And then something unexpected happened beside Lake Geneva. That summer, a 19-year-old Mary Shelley was staying in Switzerland with Percy Bysshe Shelley, Lord Byron, Claire Clairmont, and Byron's physician John Polidori. The weather was cold, wet, and gloomy. Rain repeatedly kept the group indoors, so they read ghost stories and challenged one another to invent their own. Mary struggled at first. Then she imagined a scientist kneeling beside the living thing he had assembled. That idea grew into Frankenstein, or the modern Prometheus, published anonymously in 1818. The weather did not single-handedly write Frankenstein. Mary Shelley brought the imagination, the characters, the scientific questions, and the work. But Tambora helped create the dark, rain-soaked summer in which the famous challenge took place. The same gathering also helped produce another influential horror story. John Polidori's The Vampire became an early model for the aristocratic vampire, long before Dracula put on a cape. There is an irresistible temptation to turn this into a perfect cause-and-effect legend. Volcano erupts, rain begins, Mary Shelley invents a monster. Real history is messier. The eerie summer was only one ingredient. Scientific experiments involving electricity and living tissue were already capturing imaginations. Mary's experiences, reading, conversations, and ambition mattered more than any cloud. Still, the weather shaped the setting in which those ingredients met. The group really was confined indoors by an unusually wet, cold season. Mary's own introduction later remembered the rain, the fire, the ghost stories, and the challenge. Tambora supplied the atmosphere in both meanings of the word. So one eruption was followed by failed harvests, migration, economic pressure, scientific questions, and two major branches of modern horror. That chain of events is the real fact worth remembering. Nature does not respect the borders on our maps. A volcano in Indonesia can change a European novel. Gas too small to see can affect the price of bread. A few unusually cold months can influence where families settle and which stories survive for centuries. Tambora also teaches us something about climate science. Large explosive eruptions can cool the surface temporarily when sulfur dioxide reaches the stratosphere and forms reflective aerosols. Temporarily matters. The particles eventually settle out, so volcanic cooling usually lasts years, not centuries. That makes it very different from today's human-driven warming. Volcanic aerosols briefly reduce incoming sunlight. Greenhouse gases such as carbon dioxide trap outgoing heat and can remain in the climate system for far longer. One does not cancel the other. Scientists now watch volcanoes using seismic instruments, satellites, gas measurements, and ground deformation. We can connect an eruption to atmospheric changes in ways that would have seemed almost magical in 1816. Pinatubo's 1991 eruption gave modern researchers a satellite-era demonstration. Its sulfur dioxide cloud spread through the stratosphere, and the planet cooled measurably for a short period. Instruments could follow the process that people in Tambora's time could only experience as mysterious weather. But even with modern instruments, Tambora remains a warning. The eruption itself was local. Its consequences were global. Food, weather, health, migration, economics, and culture became parts of the same story. So, did a volcano create Frankenstein? Not exactly. But Mount Tambora altered the atmosphere. The altered atmosphere helped produce the miserable summer at Lake Geneva. That weather kept a group of writers indoors, where a ghost story contest pushed Mary Shelley toward an idea that still lives 2 centuries later. A monster assembled from separate pieces began with a story that was itself assembled from separate pieces. Fire beneath an Indonesian island, sulfur in the stratosphere, snow in June, rain on a Swiss lake, and one young rider staring into the dark. That is how a volcano stole summer and helped give the world a monster. If you enjoyed following one strange fact all the way around the planet, subscribe for tomorrow's story. Pip and I will be back with another fact that gets much bigger the closer you look.